Hello friends, today I'm going to teach the topic Binomial Theorem. Many students have doubts on this chapter and are unable to understand the theorems. So I have taken all these theorems from Arihant textbook, page number 351 as you can see. So the first expression x plus a whole to the power of n equals ncr x to the power of n minus r into a to the power of r. N can take any values from 1 to infinity. R can take any values from 0 to n. So the total number of terms can get calculated by n plus 1. Just take the exponent and add 1 to it and you will be able to get the total number of terms. The next expression x minus a whole to the power of n. When you get an expression like this, the general formula of this is minus 1 whole to the power of r ncr x to the power of n minus r into a to the power of r. Again, n and r hold the same values, that is r can hold any value from 0 to up to n and n can hold any values from 1 to infinity. Put x is equal to 1 and a is equal to x and you get the next expression 1 plus x whole to the power of n, which is equal to ncr x to the power of r. The general formula of this expression is this, which can be further expanded as in the form nc0 plus nc1x to the power of 1 nc2 x to the power of 2, where x powers are increasing and c powers also are increasing. R powers are also increasing. And the last term would be ncn x to the power of n. So you will be ending here. The general term as explained here is same. So such a type of expression is also called expansion of 1 plus x whole to the power of n in ascending power of x. Put a is equal to 1 and you get the next expression x plus 1 whole to the power of n. The general formula of this is ncr x to the power of n minus r. N and r hold the same values as before, which can further be expanded as nc0 x to the power n plus nc1 x to the power n minus 1, nc2 x to the power n minus 2, and so on up to ncn. Put x is equal to 1 and a is equal to minus x. The new general formula will be 1 minus, the new expression will be 1 minus x whole to the power of n, which is equal to minus 1 whole to the power of r into ncr and x power of n. N and r hold the same values as before, further expanded as nc0 minus nc1x plus nc2x square, and x powers are increasing, c powers, r powers are also increasing. But remember that there's plus and minus, alternating plus and minus signs used here. This goes on up to ncn x power of n. When there's an expression like x plus a whole to the power of n plus x minus a whole to the power of n, then it can be expanded as 2 into nc0 x power n a power 0, which is nothing but 1, plus nc2 x power n minus 2 a square, plus it can go on up to ncn. So n and n is not, n here is the exponential unit as can be observed from here. x plus a whole to the power of n minus x minus a whole to the power of n. To expand this, you have to use this general formula. 2 into nc1 x power n minus 1 a power 1 ncr plus ncr x power n minus 3 a cube and gone up to ncn. R powers are incremented by plus 2, n powers are decremented by minus 2, n minus 1 and n minus 3. So if the exponent is odd, that is n, if n is odd, then the expressions x plus a whole to the power of n plus x minus a whole to the power of n and x plus a minus x plus a whole to the power of n minus x minus a whole to the power of n, both will have n plus 1 by 2 terms if n is odd, and if n is even, the number of terms is equal to n by 2 plus 1 only for x plus a whole to the power of n plus x minus a whole to the power of n. The number of terms is equal to n by 2 only for x plus a whole to the power of n minus x minus a whole to the power of n. For x plus a whole to the power of n, tr plus 1, the tr plus 1th term is equal to ncr x power n minus r a power r, where n and r hold the same values as before. For x minus a whole to the power of n, t of r plus 1 is equal to minus 1 whole power r into ncr x power n minus r into r. When it is minus, you have to put minus 1 whole to the power of r, else there is no need of minus 1 whole to the power of r when there is a plus. For 1 plus x whole to the power of n, t of r plus 1 is equal to ncr x power r. For 1 minus x whole to the power of n, t of r plus 1 is equal to minus 1 whole to the power of r into ncr x power r. Again the same thing. When there is plus, there is no need of the minus 1 whole to the power of r. When there is a minus, there is a need for minus 1 whole to the power of r, ncrx power r. So as of now, there are only so many formulae that I have encountered. Thank you for watching.